All right, we'll start with the presentation now. Hello, everyone. Good afternoon and good evening to one and all present here. Welcome to technical session 2A. Myself, Deepika Jain, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Congress on Information and Communication Technology, ICICT 2023, London, United Kingdom. The 8th edition of the conference is being organized in a hybrid mode. The physical event was held in London on 21st February, and the virtual event will be held through Zoom today and tomorrow. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presenters, and the presenters will be given 12 minutes for their presentations and 2 to 3 minutes for their question and answers. On 10 minutes, I would be giving you a time check. All right. So please, I just request all the presenters to keep a note of the time frame, as well as like we have other sessions in the parallel as well. So we do not want to delay those. Yeah. And there is another request for all the participants to stay connected till the end of the session. And if you have any query, you can contact me through the chat box. And just before we get started, just a minute. I would like to introduce to our session chair, Nikolay Pavlov. He is currently working at the Department of Combustion Engines, Automobile Engineering and Transport, Technical University of Sofia. His research interest is in automotive engineering. Their current project is the study possibility of reducing impacts that cause thanatosis in children when traveling by car, competition for financial support for projects of junior researchers, etc. And he's currently the Associate Professor of Technical University of Sofia, Bulgaria. I welcome you, sir. So would you like to tell about yourself for a minute or something, a quick brief about yourself, sir?
Hello, everyone. As you they introduced me, I will be chair of this session, and maybe we have to start with the first report.
Okay. Yes, sir. Yes, sir. We would be starting now. So we have our first presenter, Vidyut Saha. Are you here?
Yeah, hello. Am I audible?
Yes, sir. Just a minute. So you will be presenting a paper on concept for using 5G as communication backbone for safe drone operation in smart cities. Yes, sir. You can start sharing your screen.
Yes. Am I audible and visible?
Yes, yeah. Yes, sir. You're audible and the presentation is visible as well. Please go ahead.
Okay. Thank you very much to give me the opportunity to present our work. I'd like to welcome to everyone to my slot of presentation. Today I'm going to present our paper, Concept for using 5G as a communication backbone for safe drone operation in the smart cities. Within this paper, I myself, Vidyut Saha, along with my colleague Stefan Kunje, work together from Deggendorf Institute of Technology, Freiburg, Germany. In today's presentation, I'm going to cover following topics: Simulu project, Geo awareness system, smart city concept, 5G and UAVs for smart cities, concept for safe UAV operation in the smart cities. Under this topic, I'm going to cover 3 more subtopics, all in one: concept for using 5G, inter-UAV communication scenarios, improved geo awareness system. And eventually I will be ending with the conclusion and the future scope of work. So to begin with, Simulu project deal with safety and security in the lower airspace. At the moment, civilian UAVs, that is unmanned aerial vehicle, which is commonly known as drones, which are mostly operated in the unregulated and uncontrolled manner in the lower airspace. Mostly drones are used for the recreational purpose. So drones are broadly categorized into two groups: cooperative drone and uncooperative drone. Cooperative drones are those drones who obey all the safety rules and regulations. Uncooperative drones are those drones which is mainly operated by some criminal activities. So uncooperative drones really are big threats for the security system. So overall goal of the Simulu project is to design a concept and prototypical system which can ensure the safely integration of cooperative drones within the lower airspace, and it also eventually handle the danger arises from the uncooperative drones. So within this project Simulu, we from Deggendorf Institute of Technology work together various industrial partners, and this project was funded by German Federal Ministry for Digital and Transport. So far what we have deployed as of now, we have deployed one geo awareness system. This is you can say a drone security system based upon the dedicated radio frequency communication channels. The UAVs are equipped with UAV adapter, and one part of this system, that is most right hand part is the Simulu central system, and the other part is the end user for normal manual driven drones. And otherwise, if drone is driven by the autopilot, this could be a ground control station. So this UAV communicate with Simulu central system and as well as the end user. If eventually some danger situation arises, in that case, in case of manually driven or manually guided drone, the safety instruction is communicated to the end user or the pilot. And in case of autopilot UAVs, the route configuration update message is transmitted to the ground control station. So far up to this, we have already deployed, and it has been tested for the manual driven UAVs and as well as the autopilot UAVs, and it is working fine. So next, what is a smart city concept? As we all know, that smart city brings intelligence into the urban life to ensure comfort and safety for the civilians. Smart city mainly deal with two major equipment, that is Internet of Things and artificial intelligence it brings to the urban planning. Smart city mainly target 6 sectors of the lives. For example, smart living, smart economy, smart people, smart mobility, smart environment, and smart governance. So now we will try to understand a little bit about the relevancy of the 5G technology and UAVs for the smart city perspective. 5G is the upcoming communication technology which can ensure all the communication need for the smart cities. 3 basic characteristics of the 5G. For example, enhance mobile broadband, which ensure the huge data requirement of the smart cities. Ultra reliable low latency communication is ensure the almost latency free communication which is required for the communication between different objects within the smart cities. And massive mobile type communication which can ensure or which can handle huge number of IoT devices. So we can say that 5G, the main motto of 5G for the smart city concept is it wants to ensure the information in the fingertips. And then what is importance of the UAVs? That we already know that UAV are not confined with the recreational purpose anymore. Now UAVs can use for transportation of the goods. UAVs can use for transporting the life-saving drugs in the rural area. UAV can be used for the traffic control system, and eventually UAV can be useful for the agricultural sector also. So we can say these 5G and UAVs are two most essential parts in near future for the smart city concept. So we understand that in near future, in the lower airspace of the smart city, the number of UAVs will be increasing. So we have to secure the movement of the UAVs within the smart city. Keeping this concept in the mind, we develop one concept for safe UAV operation in the smart cities. So what is our concept? We propose a all-in-one concept using 5G for the UAVs. So at the moment, all the UAVs are deals with different kind of signal, starting from command and control, telemetry, sensor or video streaming, transponder message, etc. Each and every communication channels require a separate kind of communication specification. As of now, no communication technology can handle the communication need for all such type of communication channel. We have discovered that 5G has potentiality to handle the communication need which is required for all these type of communication channels. So we propose a all-in-one concept using 5G to handle all this communication needed by the UAVs. One more thing I want to mention here, the network slicing capacity. The 5G has a special facility to bifurcate the entire network in the virtual pieces, and we can configure one special virtual pieces of the 5G network to handle the UAV traffic. We also propose the inter-UAV communication using 5G network. Inter-UAV communication is important to handle the collision within the drone inside a drone swarm. There exist two types of communication possible within the drone swarm. One is all possible communication via UTM system. That means UAV traffic management system, which is the ground station. And another possibility is that UAV can communicate each other directly. In our concept paper, we propose a mixture of this communication system. For example, in case of bigger picture, that means flight path related information and these things should be communicated via UTM system, and which is useful to detect the possible collision. And once the collision is detected, UAV can communicate each other directly to avoid the collision or to plan some mitigation plan. So overall, we can say the UTM takes place for the collision detection, and direct UAV communication can handle the collision avoidance scenarios. So what will be the benefit to use this all-in-one communication concept for the geo-awareness system? Firstly, we can use the already existing 5G infrastructure for the UAVs.
Dear presenter, you just have 2 minutes left.
Okay. So we can handle we can use the existing 5G infrastructure. We will just reduce the cost of new infrastructure. Secondly, the UAV traffic can handle, or we can say 5G spectrum can be handled by the UAV traffic and the cellular user. And one more feature of 5G, that is virtual reality or augmented reality, can be useful to give the more realistic guidelines to the UAV user. So eventually, to conclude the presentation, I already said this is a concept paper where we are proposing 5G as a communication link for the UAV communication. So as a future task, we'll try to implement this all in one concept for inter-UAV communication, and we can evaluate its feasibility for the UAVs. So eventually I reach to my end of my presentation. At this point, if we have any question, we can discuss, or otherwise I can say thanks for your attention.
Yes, sir. Any questions? So you are on mute, sir. So
Are there any questions from the other participants?
the participants can also drop their questions and query in the chat box in the open chat forum as well. Any questions and from your side, sir? All right. Then can we move forward?
I want to ask, what about the disturbance of the system? Is there any safety reason for interference and the other things for this type of systems?
You mean what are the safety threats for the
Yes.
the fictitious drones? Yeah, obviously. For example, like you can say at the moment anybody can purchase one drone and can fly the drone. There is no licensing system. So the uncooperative drone can be fly within the airport or where the safety measures are very important. They can capture the information or security system from the airport, and and eventually they can plan some activity or attack system. So our proposal or intention is to design one prototype which obviously can control the cooperative drone. They can assist the cooperative drone user, but eventually they can mitigate the safety threats arises by the uncooperative drone also, or to change their flight path or their velocity or like that. So this is the main concept of Simulu project.
Okay, thank you.
Welcome.
Thank you, Vidyu. Thank you for your presentation.
Thank you very much.
Okay, thank you. So we have our next presenter with us, Yang Lu. He would be presenting a paper on construction scheme of innovative European urban digital public health security system based on fuzzy logic, spectrum analysis, and cloud computing. We welcome
Yeah,
you
yeah.
here.
I'm
Yes,
here.
yeah.
Let me share my screen.
Screen, please.
Okay. Okay. Oh, yeah. My topic is the construction scheme of innovation European urban digital public health security system based on fuzzy logic, spectrum analysis, and cloud computing. I'm from Ukraine. I study at Kharkiv University, and the job is a little difficult. Let me see next. This is the outline for my job, the introduction, and what we did in the previous job is portable digital stethoscopes. And detection technology we also have realized, and the time complexity. This is calculated in this job for calculate the cost for building such a system. And then next is the scheme, and then this is the assessment for the technical requirements for such a modern systems for our European smart cities. And also there is some comparisons between our work and what other people did. And next is the conclusions and references and acknowledgements. The last is the information and the contact of the author. So in face the public health security incident, what need to be addressed? People always focused on the medical resources and medical technologies and the medical policy measurements, but in fact there is also exist other factors needed to be considered. For example, the planning of the city and the digitalization of the city and the structure of our modern city control system. And I think anyone don't wish a lockdown is not so satisfied memory for all of us. And the subject of our job, in fact, focused on the acoustic noise list of respiratory sounds, breathing sounds. And the work is based on previous results about the feature separation of breath sound. And, in this job, we present the scheme and the critical parameter accreditation and the realization and the future challenges for the urban digital public health security system, and this the meaning of the system for the smart city and the digital cities. This is the signature technologies, and this is our previous device. This is what we proposed and what we did. This is a portable detect phone. This is the interface of our previous job, previous APP or previous detection. And there is some typical parameters for us to use based on other jobs. And this is classification of types of basic respiratory sounds: the tracheal sound, normal or unnormal lung sound, and the stutter and wheeze and squawk, fire crackle or coarse crackle. And the important parameter here can be divided the occurrence of frequency and occurrence for the time. Yes, if we can get this parameter, it's better. But for realization, we need to consider many factors, and also as if we use APP, then for the users, we wish the time delay is no later than 10 or 20 seconds. Yeah, it's better. We can quickly get the response from the digital center. And this is the other people did. They did use the spectral analysis for normal crackle and the visual this typical breathing sound and the spectrogram and the computer metrics for compare. And this is the time complexity of the algorithm which we use, the one-dimension FFT, fast Fourier transformation, two-dimension fast Fourier transformation on choosing operation, computing the covariance matrix and the multiplication. And the time complexity of the entire algorithm calculation is by the following formula. And for our job, in previous job, we have found that the sampling, we use the sampling frequency of 44,000, and 100 hertz, and we can get overlap of the relation can be achieved. It is approximately 95% confidence level is enough, for us. And here we design that the duration time of each collection was set to 30 seconds. So the time resolution can be reached 10 microsecond, and If we divided the signal into 3,000 segments, then the frequency resolution can be reached to 100 Hertz. And in this case, the time complexity will be the following. Yeah. There, O1 is a constant order, yeah, representing the minimum running time for the computer to perform one operation. And this is our scheme of innovative European urban digital public health security system. This is the user, and this is the classifier law, and this is the physiological control model, and this is the social management section. We can make it more simple. Yeah, this is the framework. M means the measurement model, and I and D means the identification and the digital processing model. C is the control model. And for other people, what the Dr. Umers read, they make a review of the technology with what we use, and we can see the camera-based technology. We need the camera and the ultrasound-based technology. That is what I use here, and the X-ray imaging is very high cost. CT scanning also very high cost. RF sensing is is necessary for data transmission, but if I just put a sensor on the body, it's very strange. And yes, it's as regular next step is a feature extraction, and we get the spectra, and we use AI technology to analyze the structure, and we make a division of the decision that it and identification, is it healthy or unhealthy, or this is COVID or not COVID. But for us, we just use two measurements. Yeah, two measurement device. The first is very normal. We can see that the kick, test kick, yeah, rapid test kick. The two line, test line and the calibration line. If the test line and the calibration line is visible, then we can say that, yeah, these people may be active for COVID. And the next step is to use the Pearson correlation. Yeah. What is that? Yeah, a Pearson correlation coefficient. Yeah, and this is to calculate the this is a matching method. In fact, to find which one is which one can match the standard or the typical COVID significance. And here a variable presents the results of the quick kit test result, and also the breathing sound, the chapter of breathing sound. And how we get the breathing sound, the feature or the chapter, we can use many AI technologies. Umers spread I have also listed here. But it's very complex, not so simple to realize for a very simple APP. And so I propose a method based on fuzzy logic. Yeah, we can build the membership membership function, and then to define to conclude the patient or the user is a symptomatic infection or mild or severely. Yeah, and then what is important is next then control model. This is very important to deliver to allocation of.
Sorry for the interruption, dear presenter. You have 2 minutes left.
Yeah, okay, I see. Yeah, to allocation for the resources to give mask, to give food or vitamin or medicine, or just ambulance. Yeah, to adaptation for the medical resources to release the pressure of the doctor and the hospital. And this is a specific calculation static results for some modern European cities. And this urban population density is very important parameter we need to consider. And this is take Spain and an example. You can get this picture from this site. Yeah, it's Daily Max and border police lockdown or not lockdown, and infection span in European minimum maximum. And this is yeah also. And the structure framework, in fact, is based on the Scientific Research Center. It's a remote control or the remote monitoring or remote controlation system. In fact, yeah, and also this is other people did. It's just like us, but we have differences in this law and different algorithms. And also these people use the doctor as male, use CT scanning machine learning. But the first stage is to you need to take patient in the hospital. This cannot be realized in home. And this is a regional international connectivity infection rate based on 3 European countries, many cities in Europe, yeah, England, Italy, Germany. And it shows the importance of the city connectivity in the role of spreading COVID. We can see here, yeah, transport, yeah, need to be considered here. And this is conclusion. The conclusion is that our method based on physiologic and IOMT, in fact, Internet of Medical Things, to give a more better, a better or more reasonable or more efficient scheme for the smart city realization. And when face the future crises, just like COVID and earthquake or any other nature hazard, we can use this system to make decision and to make to save more people. Yeah. And when our data transmission technology more advanced, we can use the 5G, 6G technology to do operation. Yeah. Remote operation. Yeah, it's also very better. Yeah. So this is the references of what I say, what I use, and this is thank you for your attention. And this is information and the contact of the authors. We did many jobs, but it's very difficult in just 15 minutes to address it. Yeah, thank you very much. Yeah.
Thank you for your presentation. Sir, any questions? Okay, thank you for your presentation. We'll move forward. Sir, any questions, sir?
Maybe I want to ask, we know that the saturation or oxygen level was the main parameter for COVID. What about this parameter? Can you compare the two parameters of the breath noises and the saturation? Can you compare like diagnostic parameters? What is the difference? What of these parameters is most informative the breadth or saturation of the where they measure on the finger oxygen in the blood, or we don't have you don't have information about this parameter?
In fact, I have read some other papers, and they have gave these parameters. But in this PPT, I haven't shown this. And this system, what I proposed, more generally. In fact, it can be used not only COVID situation, but also other lung cancer situations. You can see, and so this is a scheme. This is a scheme for how to deal with the public health crisis. Yeah, in fact. And this also based on our previous job. We have also we 2020 year, yeah, in 2020 year we finished one project about how to use the digital technology processing the lung sound to do a diagnostic, and we have published one paper. And based on this job, we developed this system. Yeah.
Thank you. And how is the situation in Kharkov now?
The Kharkiv no, sometimes without electric, sometimes without electric. Yeah, and every time when police is have some victory, and the situation will be worse because Russia not satisfied, and they will send a missile. Yeah, and we have alarming this music. But in general, people live here, and central city work normally. Yeah, don't worry, don't worry.
I wish you the better time for you in the future.
Yeah, peace. Yeah, we also wish peace, but I think it's very quickly we will get it. The victory is not so far from us. Yeah.
Okay, thank you.
Thank you very much.
Thank you. So we have our next presenter with us, Lilia Raikeva. She would be presenting a paper on critical junctures in contemporary media and communication processes. I welcome you, ma'am. You can start sharing your screen.
Okay, thank you very much. Let me see.
I can see your screen. You can start.
Yes,
Yes,
is it
please.
okay? All right.
Yes.
Thank you very much. My name is Lilia Raicheva, and I come from Sofia University, the St. Clement Okhridsky Sofia University, Bulgaria. And I'm here to present our paper, which is entitled Critical Junctures in Contemporary Media and Communication Processes, on behalf of my co-authors who are listed here. What is the subject frame of our presentation? I would like to point out that the research is part of the Media Delcom project, Finding Risks and Opportunities for European Media Landscapes of the Horizon 2020 program, which is the European Union funding program for research and innovation. And our case study provides analysis of some of the critical junctures in the Bulgarian media ecosystem developments. What means a media ecosystem is the combination of traditional media and online media. And the research is based on major digital sources and data sets on media and journalism within 20 years period of time. The research has been done in 4 domains: legal and ethical regulation, journalism, media usage patterns, and media-related competencies. The methods we used were dual quantitative analysis, which are the measurable data, and qualitative analysis connected with the interpretation of specialized texts, interviews, and also online observations. In addition, we applied cross-combining technique for data collection and analysis in order to compensate some of the inherent limitations of the study. What are the current trends in the Bulgarian media developments? We used another methods, a very popular one, which is the pest analysis, and it connects the issues for political, economical, social, and technological variables while analyzing the media ecosystems. So, what were the basic risks and opportunities of the media developments that we found out? And these are parts of our findings. The major issues that are decisive for democratic functioning of the human-centered societal developments turned to be firstly, the legal and ethical regulation domain, and for the proper functioning of the contemporary media ecosystems in terms that a number of political issues are becoming increasingly important. We have to start first with the freedom of expression, which is connected with also with the access to information, connected also with the vulnerability of certain media groups, the ethical issues, and the media accountability. A very important issue is the cooperation between legal regulation, the self-regulation, which means the regulation of media themselves, and the co-regulation, which is a combination of legal regulation, self-regulation, and the participation of civil society. On the third place, we found out that the expansion of social media and social networks is very important. We distinguish between social media, we connect it with the blogosphere, and social networks, the connection between people. And finally, also the media legislation and digitization, and media legislation is lagging behind, as lagging behind are some of the economic and business models of sustaining media developments. Further on, in the journalism domain, firstly, very important is the market developments with regard to media ownership and media concentration. And in this sense, the public service media is kind of squeezed and lagging behind, and more or less it's in order to stay stably on the media market, it also has to be commercialized. Very important issue is the political and corporate independence of the media, and that's why these are two mutually bounded processes: the politicization and commercialization of media, and vice versa, the mediatization of politics. Of course, very important in this domain are the content production, or the working conditions of people who work for the media, and the professional initiatives against disinformation, which includes fake news, post-truth, and the cancel culture. In the third domain, the media usage patterns domain, we found out that there is the growing usage of hybrid products in the convergent communication reality. Pluralism and of opinions and variety of contents is very important in contemporary social developments, and the professional attitudes of journalists against the imposing certain points of view and not allowing for other points of view to be heard by the broader public is also an important issue. Very significant in the current situation is access of different societal groups, ethnic, religious, cultural, linguistic, age, also to the variety of media channels. In contemporary times, through the fast development of the information and communication technologies, a very interesting phenomenon is observed, namely, this is the information overload and the digital fatigue, which is related mainly to news media and reflects the trust in media and also the transformation of audiences from passive consumers to active prosumers. Here, I would like to explain the word prosumer. It has been coined out in the 80s before the advent of internet by Alvin Toffler in his third wave, and it combines two words, producer and consumer. And in contemporary times, practically everyone can be a prosumer. And the last domain is related with the media-related competencies, which is directly linked to the expansion of the online platforms and the artificial intelligence. And it brings with this the issues of media literacy, and not only media literacy, but also digital and information literacy and the media ecology in initiatives. As I mentioned before, these initiatives are strongly linked to the fake news, to misinformation, post-truth, and the cancel culture. All these problems are very challenging for the professional standards and the journalistic ethics, and for the protection of underage and vulnerable social groups. The process of the metization of net and vice versa, the internetization of mass media, has helped the digitized traditional media to switch over from an extensive to an intensive phase of development. As I said, all these issues are of major importance, and they're expecting for their decisions to the whole area of stakeholders, such as media institutions, content producers and providers, advertisers, regulators, academia, civil society, and prosumers. In conclusion,
Sorry for the interruption. You have 2 minutes left. Please
thank you very
continue.
much. I have 2 slides for the conclusion. The rapid developments of the ICTs, they outline the horizons of the audience's inclusion in several aspects. Firstly, politically, with the development of free and unhindered transmission and distribution of audiovisual services, needs a contemporary legal and regulatory framework. Economically, the expanding tendency towards deregulation and privatization in online and offline production and distribution of audiovisual content leads to a larger dependence on market mechanism. Socially, the contemporary ICTs environment has an ambivalent impact on media consumption, and the quantity of program often leads to fragmentation of audiences and to their broader participation in the audiovisual creative production and dissemination processes. And finally, in technologically terms, the contemporary audiovisual reality becomes more and more complex with the interweaving between linear and non-linear programming, as well as between broadcasting and the audiovisual service, which is challenging the human-centered communication in the contemporary media ecosystem. And finally, I would like to acknowledge the Media.com project of H2020 program of the European Union. With the kind funding of this paper has happened. Thank you very much for your attention.
Thank you so much for your presentation. Sir, any questions? All right. We'll move further. So we have our next presenter with us, Stephen. He would be presenting a paper on IoT infrared imaging of livestock tissues using a one-eyed bandit technique. I welcome you, sir.
Thank you very much.
Yes, sir. You can start sharing your screen.
Yes, of course. Can you see my screen?
Yes, I can see your screen.
Okay. Okay. So, good afternoon to everyone. My name is Stefan Izanov. Today I would like to present our paper titled IoT infrared imaging of livestock tissues using a one-eyed bandit technique. I am from the Technical University of Sofia, Bulgaria, and this work is done by Professor Peter Yakimov, Associate Professor Dimitar Tudorov, and me. So let me first start with some motivation behind our work and what we have developed. The motivation behind our work was to develop a system which was aimed at precision healthcare monitoring of animals within the field of farming. And we wanted to utilize some techniques and develop some of our own that would potentially increase the measurement accuracy of a system which is a thermographically based system for non-contact biomedical diagnostics. Additionally, we wanted to apply some algorithms for object recognition, data filtering, and compensation of parasitic effects, which would make possible the automation of such a system and make such a system scalable and implementable in a real farming environment. So this is a photograph on the right of our developed hardware platform. It essentially consists of three PCBs. As you can see, one is titled master board, which is based on the STM32 ARM Cortex microcontroller. We have a PoE power over Ethernet type of power supply to the system. We also implement Ethernet-based communication with this platform. This makes it feasible that within a farm environment, only Ethernet connectivity and PoE injectors are necessary for such a system to be installed. Additionally, we have a blinded matrix board, which I will discuss in a little more detail. Further on, imaging of the animals is performed by an infrared grid sensor AMG 8833, with one being uncovered and one being covered by a regulated heating surface. We additionally have a SD card for data storage, and we also have on the TOE board a time-of-flight distance sensors, which can in a controlled manner measure the distance between the camera device, our developed system, and the animal under test. So what is this one-eyed bandit technique that we essentially developed? We propose a ratiometric type of approach in which we know the thermographic parameters of a tissue which is being analyzed, and under a controlled heating process, we heat up through a regulator a tissue with the same thermographic parameters as the one that we observe, and we measure its temperature in a contact manner via a thermistor type of circuit, and we also, with the blinded same infrared sensor, measure its infrared emission. And through that information, we develop a correction coefficient, which we apply over the raw sensory data for the uncovered sensor. In this way, we hope to compensate for spurious external influences over the captured infrared imaging data. In order for our system to be automatable and to be able to detect the presence of an animal and where it is located within the image, we developed object recognition software, which is essentially constructed by these three functions, which is constructing image object mask based on gradient method, a quick object mask, which essentially measures the dynamic range within the infrared captured image, and based on that sets a threshold for the image object mask construction function. And also we developed a function which extracted the object from the object defined pixels, the minimum, maximum, average, and median temperatures of that. We developed a test setup, which essentially is a controlled heater with tissue, which is a real sheep tissue. And also, as you can see, we have a patch of the same tissue type covering the in the blinded matrix infrared sensor. These are examples of the two types of objects that we analyzed: object A, which is a sheepskin, and object B, which is a electrically insulating tape of an emissivity of 0.957. These are some of the example thermographic images that we captured from the reference sensor and from the main sensor at different distances. This is the raw data on the left side, as you can see, and on the right side, we applied some additional filtering. We applied heating of the observed tissue to follow a sinusoidal form, which makes it close to methods typically used in lock-in thermography. We also captured the differences between the measured contact temperature and the raw infrared temperature. On this table, we listed the results, and from our results, we found out that the average and median temperatures are most suitable for evaluating and are most closely correlated with the contact measured temperature changes. So minimum and maximum temperatures are not good indicators of that. This is two graphs representing the raw sensory data on the left, and after applying the one-eyed banding technique, as you can see, there is a more close correlation between the measured infrared temperature and the contact measured temperature than when using the one-eyed banding technique compared to having the pure raw infrared data. Additionally, we performed measurements at different distances. Distance typically has an attenuating effect over infrared radiation. So as you can see, when increasing the distance from 250 millimeters to 350 millimeters, the temperature, which was measured by the infrared sensor, dropped by roughly 0.4 degrees, 0.3 degrees. We perform measurements at different distances. As you can see, this downward slope can be visualized and also can be modeled. And in order for us to compensate this effect, we captured the several points which are at the maximum and minimum points of measurement temperature, and we applied a polynomial regression model which fit quite nicely to our measurement data, and we implemented this formula resulting from the regression model, which essentially defines correction coefficients, which has to be taken into consideration when the distance camera to animal distance is known. This distance is known by measuring with the time of flight sensor. And after we applied also the distance correction, these are the end results. As you can see, at the peaks of the contact measured temperature, from the contact temperature is 45.6 degrees, 64 degrees, and through our methods and through our compensation techniques, we were able to manage to measure 45.66 degrees. So roughly within this transient analysis and distance analysis, we were able to perform measurements with an accuracy of roughly plus or minus 0.1 degrees relative to what the real contactly measured temperature is. So as a conclusion, we presented our developed prototype embedded thermographic system. We proposed and utilized this one-eyed banding technique, which is a novel hardware approach. We additionally developed and applied some algorithms for automatic object recognition, some data filtering of the moving average type, and device-to-object distance effect compensation through the built regression model. From the capture data, we show that the detection and measurement accuracy of temperature variations can be performed with an accuracy of 0.1 degrees Celsius using purely non-contact infrared captured thermograms, which is essentially was our main goal. And on the behalf of the whole authors team, I wholeheartedly express my gratitude for your time and for your attention. Thank you.
Thank you for your presentation. Are there any questions from the other participants here? Maybe no. Okay, and let's start the next presenter.
Yes, sir. Our next presenter is Milind Patel.
Yeah, hello everyone.
Yeah. You can start sharing your screen.
Yeah, I hope I'm audible now, so I'll start my
Yes,
presentation.
you're audible and your screen is visible as well. Please go ahead.
Okay,
Thank you.
perfect. Then first of all, I'm Milind Patel doing research work at the IFM Institute of Hochschule Kempten University, that is basically located in Germany. And on behalf of my co-authors, Rolf Jung and Yasin Chakir, I would like to present you on the topic of simulation-based testing of foreseeable misuse by the driver applicable for highly automated driving function. Moving on. Yes, first and foremost is the agenda slide to guide through the content of this presentation. The first section provides a brief introduction to the concept. The second section refers to the descriptions of a SOTIF related misuse scenario. I will explain that in the later slides about the SOTIF. Then the third section outlines the strategy that is applied or deployed for this work in order to implement the simulation-based testing of foreseeable misuse. And the last section includes the conclusion and perspective of the further work that can be done for the same concept. So the introduction chapter contains the insight into the topic of safety of the intended functionality and the foreseeable misuse, its research background, its significance, with a brief introduction to the concept. To begin with the research background and significance of the topic, ISO 21448 is the standard for safety of the intended functionality. So that is abbreviated as SOTIF. So SOTIF is about ensuring the absence of unreasonable risk due to the reasonable foreseeable misuse by the driver and the functional insufficiencies related to the sensors and the algorithm. The focus of my work is on the foreseeable misuse by the driver. So foreseeable misuse implies the anticipated system misuse by the human driver. A typical example of foreseeable misuse of an automated driving system in real driving scenario is here depicted in the right side image, as you can see. So that's the underlying motivation to focus on the simulation-based testing of a foreseeable misuse. First is to address the human factor issues in the event of automated driving system failure. For example, the driver's understanding of the system's capabilities and limitations, the driver's responsibilities, and the driver ability to understand and respond to the warnings and the alert that is provided by the driving system. So basically, this work focuses on implementing the driver vehicle interface that permits the interactions between the driver and the system. So let us understand the basic concept of this work. The driver is the human operator. It's highlighted in the green color block of the automated driving system that is highlighted here in the gray block. And the automated vehicle is in the blue box. So basically my automated vehicle is equipped with the automated driving system that provides the commands such as driving commands such as acceleration, steering wheel angle, and my driver, the human driver, can perform the driving task. Now is the driver vehicle interface. That's the implementation. So it's the interface between the driver to driver, automated driving system, and automated vehicle that permits the human driver to interact with the system. So by means of providing warning, system information, state of the operation, anyone can engage and disengage with the system by means of activating and deactivating the system functions. So the driver vehicle interface, abbreviated as DVI, is designed to support the driver with the information of automated driving system functions and the states of operation, so the human driver can conveniently perceive, comprehend, and act upon the information. Moving on to the SOTIF related misuse scenario that is systematically described and modeled in order to perform for simulation-based testing. Let's say the scenario is shown here, and the scenario is defined to expose the human driver to a situation that requires the transverse guidance, which is basically formed by lateral and longitudinal maneuvering of the eco vehicle in a high-speed and highway environment. Ego vehicle in the context of this publication of the work is defined as an automated vehicle equipped with the automated driving system. So the entire scenario is divided into 3 maneuvers. One is the lane change from right to left, overtaking of the lead vehicle here, and then after the overtaking, lane change from left to right. That's the entire scenario, and the trajectory of the ego vehicle of the entire scenario is shown by the black line. The lead vehicle is the truck, and there are the 2 traffic vehicles in the adjacent lane. So the SOTIF related misuse scenario, just recall the image from the previous slide. So the ego vehicle encounters a road with the missing lane markings. As you can see, the lane markings are missing because of assumption is the bad weather conditions. Let's assume snow or rain. During automated driving on a 2-lane one-way highway and executing a lane change maneuver from right to the left lane. In that case, because of the missing lane marking, the camera sensor cannot estimate the location of the lane boundary due to the performance insufficiency. And then you can see the ego vehicle starts to leave the lane, and the driver is notified to take control of the driving task by the means of takeover request from the system. In that case, we assume the factors for the 4/7 misuse considered in this work are driver's recognition and judgment. Simultaneously, we can say false recognition and misjudgment by the driver are the causes for 4/7 misuse. False recognition is analogous to the perceptual errors, where the driver's perception of the environment differs from the reality, and the misjudgment is akin to the decision errors, in which the driver decides on an incorrect action for the given situation. As a result of the above mentioned factors and causes, the driver may fail to take over control of the driving task within a certain or specific time, and can make you false driving input. For example, delay takeover or the oversteering, understeering, and it may result in the lane departure of the ego vehicle. So that's the hazardous situation. Now the scenario is described. The vital challenge is to perform the simulation-based testing for the same scenario. And in order to carry out that, the driving simulator is illustrated here. So we have the setup. The driving simulator allows the driver to control the ego vehicle in a virtual test environment. And the driving simulator is equipped with a gaming tool. That's as a hardware, we have the Logitech steering wheel, pedals, and the gearbox. And it is integrated with the simulation tool like IPG CarMaker and a MATLAB to perform the simulation-based testing. Moving on with the strategy that I have used to perform the simulation-based testing on a driving simulator that I have shown in the previous slide. So the strategy is plan considering the highly automated driving function. So I'll explain this shortly, the highly automated driving function. So with highly automated driving, the human driver can engage in the non-driving related tasks such as reading, watching, sleeping, and in the event of a system failure, the driver is expected to regain control of the automated vehicle. But incorrect system understanding may provoke misuse by the driver, and that can lead to vehicle level hazard. So to start with, the automated driving system performs the automated driving of the ego vehicle by providing lateral and longitudinal control in the model scenario. On the right side image, you can see the implemented driver vehicle interface that is designed, and it clearly shows the system function, that is lane keeping assist system or the adaptive cruise control, the state of the operation by means of active or passive, and the controller is on or off. So that's the implementation. And now moving on, when the system reaches its operational limits, it notifies the driver by issuing the takeover request. So the driver takeover at operational limits and the corresponding takeover requests are not obligatory in the highly automated driving. You can see the takeover request is presented by means of visual and auditory. You can see the warnings also, and we have implemented that we got the auditory signal to the driver in form of beep sound to do the takeover request. So, but as it is highly automated driving, the automated driving system is expected to remain operational until the driver is able
presenter,
to.
you have 2 minutes left.
Yeah, sure. So until the driver is able to regain the control, the driver might not be able to take over driving control within a specified takeover time, and the forcible misuse is expected. It may lead to lane departure of the vehicle, addresses vehicle level hazard. So let's say if the driver does not take over of the driving task in the event of takeover request, the system will transition into the automated driving with a reduced functionality, and a minimal risk maneuver is performed by the system to keep the ego vehicles in its lane. It aborts the lane change and stop the ego vehicle on the side of the road in a safe manner. So moving on, the driver may be asked to take over at the end of minimal risk maneuver. So next, the driver does the takeover and transitions into the manual driving mode. You can see the image on the right side. So the driver does the takeover, but not within a specified time. So that may address as a delayed takeover and or fails to provide adequate steering input and performs a misuse. It may and leading to lane departure of ego vehicle, or it may not. So when it leads to the lane departure, the simulation is terminated, and it's not necessary that it leads to lane departure. If not, then the simulation ends successfully. So that's our test setup. And to conclude with, exemplary of the strategy that is defined for implementing simulation-based testing of possible misuse resulting from the system-initiated transitions between human driver and the system is demonstrated. So the relevance of this work is it adds to the understanding of the factors and causes contributing to forcible misuse by incorporating the concepts of driver-vehicle interface, driver system interactions, and applying them to a sort of related misuse scenario. So the fundamental premise is to incorporate and manage all the driver and system interactions. And Moving on, the incorporation of DSI and DVI to address forcible misuse is briefly described, but not has been evaluated. So a reasonable next step for the future work will be to characterize and quantify the driver system interactions, considering the aspects of human driver takeover in highly automated driving. Characterize in terms of identifying the unsafe control actions, like the lane keeping assist function cannot provide steering control when the driver drives the vehicle out of the lane, but intervenes too late. So there is a method for that as known as a systematic theoretic process analysis. So STPA can also be applied to identify the factors contributing to forcible misuse, and it's suggestible for the future work. Thank you for your attention and time, and if you have any questions, you can ask.
Any questions, sir? All right. Thank you for your presentation, Milind, so much. Thank you so much.
Welcome. So I can stop sharing my screen now.
I have done it. Yeah, so we have come to the end of this session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the entire team, thank you for your support during the 8th version and the previous 7 versions of the conference. We will be happy to see you in the 9th version as well. All the presenters would be getting their certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer board. The publication will be live in 6 months. All right. So kindly be cooperative with the team of ICICT. You would be getting your digital certificates. And I thank our session chair for chairing this session. Thank you so much, sir. This is a token of appreciation from our side. Thank you so much. And I would request all the participants to, turn on their cameras for a quick snapshot.
I want to ask, what about the last presentation, Syed Mohammed Hamedun?
No, sir, we just missed out one presenter, that is Alexander. Okay, Syed Muhammad Hamidin. All right, you have your presentation. We just arrived. Yeah, okay, sir. Sorry about it, sir. Syed? Syed, can you hear me?
Yes, I can. Do you hear me?
So sorry about this. You just admitted now, no? So you can start sharing.
Okay. Hi, everyone. The topic I'm going to present is user clustering in millimeter wave quality of service based NOMA for the vehicular network. Me, Syed Mohammed Hamidun, and my co-supervisor is Dr. Jawad Nasir Chakta. I am the PhD students in the University of Management and Technology, and also I am doing the assistant professor in the University of Law. And the topic I am going to present here is basically the user clustering in quality service based NOMA for vehicular network. The outline of my presentation, in which we have some introduction and the problem identification and the solution, and the quality and service based NOMA we can see for the vehicular to infrastructure communication, and our proposed user clustering scheme we will discuss, and the machine learning based user clustering technique we will also discuss, and in the end we see the comparison of our proposed user clustering technique and other machine learning based user clustering technique. Basically, in the dynamic nature in 6G communication of vehicular network, the very huge amount of traffic is very largely huge, and it's very difficult to provide the services and at different rate. So in vehicular to infrastructure communication, in which we exchange the information between the vehicles and the road infrastructure, the main purpose to provide the services with respect to their rates. And in heterogeneous networks where we use NOMA for the V2I, basically reason is in V2I with system with NOMA, which can achieve low latency and the high reliability. The basic problems we can see in the 6G communication, particularly in vehicular networks, there are different data rate requirements for the vehicles. They are moving on the roads. Our main problem is to provide the required service requirement for the vehicular users. So in millimeter wave NOMA, basically the users which are closest to the base station provides more better services as compared to those users which are basically far away from the base station. So in particular, the vehicular environment, when the number of vehicles are far away from the base station, so the quality of service is very poor, and that becomes the basic bottleneck in order to provide the quality of service. So we proposed the problem. Basically, we solved the problem of the SIC receiver at the base station side by applying the some clustering schemes. And we used the some clustering schemes in which we selected the unsupervised machine learning techniques, K-means and hierarchical, and then we proposed our own clustering scheme. So we basically compare at the end, we compared our proposed user clustering scheme with already machine learning based clustering techniques, and to see how they improve the overall sum rate. You can see in the diagram that there are scenario we could consider in which the base station, the multiple vehicles, which is basically served by the base stations. So in basic NOMA principle, the SIC is basically implemented according to the channel correlations of users inside the cell, due to which not achieve the desired multiplexing gain and fairness among the users inside the cell. So the ordering of users inside the cells is according to the rate requirements. That is why we consider the quality service based NOMA. So the n number of vehicles you can see in the located different locations from the base stations, and these vehicles which are located inside a cell on the base stations at different distances. So the vehicles which are closest to the base stations assigned more power comparatively to those used vehicles which are very far away from the base stations. So in particularly downlink NOMA, the SIC is decoding order is on the basis of the channel gains, which means the strongest use signals which have strongest signals which have weakest channel gain is recorded first and the subtracted from the received signal. So this process is repeated and we achieve the desired results. We propose our clustering scheme in which you can see we divide the users in a group of two users in multiple clusters rather than the more than two users. So we grouping of two users with respect to the distance, in which we can consider the scenario the user which are very near to the base station are grouped with the user which is basically very far away from the base station. So in during this way we basically achieve the high channel gain difference within the cluster and optimize and we can see at the end we can see the optimization of the data rate performance. And we consider the scenario for the number of vehicles when we consider the number of vehicles for particular 8 users, and we can propose technique we propose also the user clustering technique for consider the scenario when the number of users are going to be 12. So our algorithm is basically consists of different steps in which we initialize the number of users. We initialize the number of users 8 and 12, and these users which basically distances are placed with respect to the different distances from the base station. In the steps 2, the base stations divide the number of users into different clusters, and the third step in which in the SIC process, the users are sorting with respect to their channel gain and the data rate requirements. And we update the SIC decoding order in the step 4 and apply the NOMA transmission. In the step 5, we see the base stations properly serve all the users or not. And in the 6th step, we measure the sum rate of all the users with respect to the data rate equations. And we verify the result with respect to their target data rates requirements for each users in a particular cell. You can see in the graph, which is basically the results of the K-means method of the user clustering scenario, in which you can see in the figure A and B, we consider the number of users for n is equal to 8, and you can see the different colors of clusters, which basically plot by the K-means. These users basically are placed with respect to their distances from the base station, and we achieve the K-means cluster. K-means basically used to just belongs to the unsupervised machine learning technique, and which basically provide the results which in the form of the clusters. And we also apply the hierarchical based user clustering technique, and you can see in the dendrogram linkage, basically they execute and give us only the two clusters, and with the groups of in one cluster, the group you can see in the orange line, the group of users which basically in the cluster one, and the group of users, some users which basically 3 users which basically shown in green color is the cluster 2. So you can see in the radical based clustering techniques, only 2 clusters are to be made with respect to their distances of the vehicle from the base stations. And these are the user clustering scheme analysis, in which we can see with our clustering scheme analysis and with respect to the proposed user clustering scheme analysis, we have transmit power in x-axis and the achievable rate of the data rate in y-axis. You can see, and with our clustering scheme, the data rate is very poor. And with respect, now our proposed user clustering scheme graph, you can see the data rate performance is very relatively improved than other machine learning clustering schemes, radical and the K-means. And this is the results for the number of users when we consider for 8. And when we increase the number of the users, you can also see the performance degradation is also or more poor. And you can see in the without clustering scheme, the result, the achievable rate of the users is very poor, and our proposed user clustering scheme becomes more good comparatively to the other user clustering schemes. These are the results which basically shown in the table. We basically use the simulation parameters for the QNOMA, in which we define the target rates for we assume the target rates of the users for the Q1, the Q2, and the Q3 is basically the target rate constraints which basically assume at the base station site. And the last column, the position of the users in the clusters, you can see in the proposed clustering scheme we have 4 clusters, and the K-means clustering scheme basically build the 3 clusters, and hierarchical clustering scheme is basically the 2 clusters. The number of the positions at the clusters is shown in the set. And when we increase the number of the users 8 to 12, there are different clusters will be shown in the table, and we have the achievable rate targets, which is basically the main constraint of our parameters. You can see in this table, and according to this table, we generate the results. You can see the target rates, which is shown in the purple color, is basically our target rates, and our proposed user clustering scheme is basically can achieve more near to the target rates comparatively to the other user clustering technique. Clustering schemes. So we consider when the number of users is equal to 8. And in the next table, in the next graph, you can see when we increase the number of the users, there are different data rates which basically achieved, and our proposed user clustering scheme basically provides more better result as compared to the other clustering schemes. This is the main objective of my presentation of our research work. We can see in the end basically the problem in NOMA when the number of users to be increased, so the receiver SIG complexity is also increased. So in particularly NOMA, the SIG is basically placed, SIG decoding order is basically built on the basis of the channel difference gain. But in the quality service based NOMA, we categorize the SIG decoding order on the basis of their target rates rather than the channel gains. So this basically because the basic problem in the vehicular network, particularly the user which basically far away from the base station requires more data rate comparatively to the user which basically near from the base station. This problem is to be resolved by using the QNOMA, and this is the main problem, the V2I vehicular network. And we observe the clustering scheme analysis, which we can see which is very useful to divide the number of users in the clusters. When we divide the number of users inside the clusters, we basically reduce the SIG receiver complexity, and due to which we enhance the performance of the system. And in the end, we can see the proposed, our proposed algorithm that performs more better and improves the sum rate of the network, which is basically particularly in NOMA. Thank you so much. If you have any questions related, then kindly ask.
Thank you. Thank you for your presentation. Please turn off your cameras for a quick snapshot. Much. We can leave the session. Thank you.
Thank you very much.
Thank you very much.
Guys,
Thank you.
stay safe. Take care.
Bye.
Bye-bye.
Have a nice evening. Bye bye.
Have a nice day.
Thank you, Nikolai.